Buenos dias, Algebra 1A students. This video is going to review O2, O3 absolute value equations. If you don't already have paper and a pencil nearby, please pause the video and grab them so that way you can take notes, so you can have those to reference when you take your quiz. All right, before we get started on the equation side of it, let's just review what an absolute value is. So absolute value is representing distance, or as you can see here, it is how far away a number is from zero. So let's talk about traveling. So if you are, this can apply to a car. So on your cars, you have an odometer that tracks how many miles it's drawn or driven. It can be tracked through, if you're walking, a lot of people have Fitbits or Apple Watches, and it will track your steps. So when we're traveling in a car or when we're walking, if we're tracking our distance, if I walk, say, to a stop sign, and then I walk back home, even though I'm going back home, am I subtracting the steps that I've taken or the mileage that I've driven? No, it still continues to add on. It's still a positive number. Even if I decide to walk backwards or drive my car in reverse, it's not going to take those numbers off the odometer. It's not going to subtract those numbers from your Fitbit. You are still moving, so it is still adding those values. So that's why when we refer to absolute value, since it references a distance, since it's how far away it is from zero, that's why the absolute value is always a positive number, because even if we go backwards or if we turn around, we're still adding to our steps. We're adding to our mileage. So if we look at this example on the number line, we can see here that -6 is 6 away from zero, as is +6. So even though the value are the same, the absolute value is the distance. It's how far away it is from zero, which is why they're the same and they're both a positive number. The ways that you will recognize that you need to take the absolute value of something are our symbols, okay? So the absolute value symbols on either side, all right, are these bars, okay? So that tells you that you need to take the absolute value. You're looking for distance, so you're looking for how far away from zero, which is a positive value. So the absolute value of -5 is a +5 because it is 5 units away from zero. And you can reference that number line up here as the example. Our -5 is 5 units away from zero. Same with 7. The absolute value of a +7, it's not that it's the opposite, it still is a +7 because we are 7 units away. I don't know if you'll have any future assignments where you need to type absolute value symbols or not, but if you do, right here is where it can be found on a majority of your keyboards. All right, you'll have to hit Shift because the initial button is that \, but if you hit Shift, or you can do an absolute value symbol. Okay. So, one more thing before we get into our equations. With absolute value equations, there are always two possible answers, because if we come back up and look at this number line, both the absolute value of +6 is equal to 6 units away, but the absolute value of -6 is also 6 units away. Therefore, for every absolute value, there are actually two possible solutions. The number on the positive integer and the negative integer. So that is something we're going to carry with us when we come down and solve our first equation. So I see here that I have the absolute value of -4 plus 5x is equal to 16. Well, this absolute value right here, because it's an equation, I know that I'm trying to find, I'll make these absolute values a little bit easier to see. I'm trying to find what value of x will result in me getting the answer, the absolute value of 16. Well, as we discussed up above, I could have a positive 16 inside of there, or I could have a negative 16. So when we solve absolute value equations, because there's two possible answers, we need to split it into two equations, the positive integer option and the negative option. So this absolute value could be equal struggling with my writing here today, to a positive 16 or a negative 16, because either one of those answers will result when I take the absolute value in this positive 16. One way I've heard some people in the past refer to this is we have two absolute value bars. So that reminds you that you're breaking it down into two equations. You have the positive version, and then one of those becomes the negative version. Now, hopefully this looks very familiar to you because you just completed O2O2, which was a two-step equation. And that's what this is. The only difference, the extra step that we have to take, is we now have two equations that we have to solve. But the process is so similar. So hopefully, either this will provide extra practice if you were struggling, or it'll be something that you maybe catch on to quickly. Let's solve the blue one first. So the one that is set up to a positive 16. All right, when we're solving this equation, remember we're trying to isolate our variable x. So the first thing is anything that's being added or subtracted needs to be moved to the other side of the equation. So I see we have a negative 4. Well, what's the inverse? The inverse of a negative or subtraction is addition. So we're going to add 4 to both sides of our equation. So negative 4 plus 4 is 0, and that's what I wanted. So that confirms that my choice to do the inverse operation was correct because those zeroed out. So we're left with a positive 5x on the left, and then 16 plus 4 is 20. Now I see that it's 5 times x. So what's the inverse of multiplication? Yeah, division. So now we're going to divide both sides by 5. Well, 5 divided by 5 is 1. So that helps me know I made the right decision because that simplifies to a coefficient of a 1. So I am simply left with a single x. It is isolated. And 20 divided by 5 is 4. So that is one possible answer. If x is equal to 4, it will make that absolute value equation true. But we do have a second option over here in red because the inside of your absolute value could become a negative 16. All right, so very similar steps. We're still going to add 4 to both sides. A little sloppy, that's okay. Negative 4 plus 4 is still 0. Bring down our 5x. But this time on the right, it's a negative 16 plus 4. So what's that? Yeah, negative 12. The inverse of multiplication is division, so that's why we're dividing by 5. 5 divided by 5 is 1, so winner, winner, chicken dinner. Our x is by itself. Negative 12 divided by 5. Now, I don't have any clear directions on whether I need to represent my answer as a fraction or a decimal, so I will go ahead and represent it as a decimal. That simplifies to negative 2 and 4/10. So both of these our possible answers, all right? And if we want to just take a brief moment to double check that, we can do so. If we substitute our 4 in, 5 times 4 is 20. 20 minus 4 is a positive 16. The absolute value of 16 is 16. Check. All right, now let's double check our other answer here, our red one. 5 times negative 2 4/10 is negative 12. Negative 12 plus negative 4 is negative 16. And is the absolute value of negative 16 a positive 16? Yeah, it is. So both of those answers check out. Either one can be a possible solution for x and make that absolute value equation true. All right. Number 2. Now, what do you notice? I'll scroll back up. That's a little different between example 1 and example 2. I'm sure someone said the numbers are different. Haha, you're right, they are. But look a little harder. What's different about the setup? Hopefully someone recognized that in example number 2, we have something outside of our absolute value. Now, what that means is we need to isolate the absolute value first, because it's only what is inside the absolute value signs that represents distance. So it is only what is inside of that absolute value that can be equal to the positive or negative version. Therefore, before you can split and make 2 equations, you always need to isolate the absolute value first. All right, so off to the side here, let's make some steps. So number 1, you always need to make sure to isolate the absolute value. Then number 2, you can split into 2 equations, the positive and negative version. And then 3, you can solve both equations. So there's kind of a nice, good set of steps, okay? And I may need to scroll a little bit and move some of this so we have room to solve. I'll keep this over here for you guys. So on number 1, we need to isolate the absolute value first. So what's the inverse of a positive 3? Negative 3, so we'll subtract 3 from both sides. So my absolute value signs are still going to be here because I have not created the 2 options yet, so they don't disappear because I don't have my 2 options. 3 minus 3 is 0. 73 minus 3 is 70. Ooh, snappy. All right. So step 1, I isolated the absolute value. Now that that absolute value is isolated is when I can move in and split my 2 equations, because that 7m can either be equal to a positive 70 or a negative 70. So I just am a creature of habit and always write the positive version first and the negative version second, but it really doesn't matter. So check off step 2. Now step 3, need to solve both equations for our variable. So for this first one, the red one, our positive 70. Well, this is kind of easy. This is only a 1-step equation. You did this at 0201 with Mr. Masonoff's video. The inverse of multiplication is division. So we'll divide both sides by 7, which means one possible value for m is a positive 10. All right, now let's solve our other one, our blue negative. Inverse for multiplication is division. But here we have negative 70 divided by 7, so we'll have a negative 10. And both of these are our answers because either value for m are a solution to this equation. All right, before we go on to number 3, I highly encourage you guys to pause the video and try number 3 on your own, okay? Or maybe if you're a little unsure on how to set it up, then after we split the two equations, then pause and solve for yourself, because that's one of the best ways to learn is through trial and error, because by you completing the answer yourself, you'll have a better idea of what you understand and what's still a little confusing, what you maybe need to rewind the video for, or take additional notes on, or contact one of us for a Zoom, and we can help you out, okay? All right, number 3. So if I look back through my steps, I'm gonna clear, oh, oopsies. I guess I just need to move them down here. There we go, now I can use them again. All right, so if we look back through our steps, is my absolute value isolated? No, it's not. There's a 4 right in front of it, which my absolute value isn't a parenthesis, so I can't distribute that 4. But it is being multiplied. So what is the inverse of multiplication? Division. So we need to divide both sides by 4 so we can isolate that absolute value. 4 divided by 4 is 1, which allows our absolute value to be isolated. And 56 divided by 4 is 14. All right, step number 1 is done. Now that it's isolated is when I can split into two equations. I do the positive option first, n plus 8 equals a positive 14. Then we can split into our negative version. N plus 8 equals a negative 14. Okay. All right, again, we got some one-step equations, so that's kind of nice. It's always handy when you get to the end and it can go a little faster. So n plus 8, what's the inverse of addition? Subtraction. We'll subtract 8 from both sides, bring down our n. 8 minus 8 is 0, so that eliminated just like I had hoped. 14 minus 8 is 6. My variable is by itself, so 6 is one possible value, one possible solution. Let's do our orange one, our negative one. N plus 8 equals negative 14. The steps are the same. My inverse is still by subtracting 8. But this time it's a negative 14. So negative 14 minus 8 is negative 22. Struggle to write those 2's. There we go. And both of these are possible values, possible solutions for n. All right, you guys are doing good. We have 2 more examples in this video, okay? All right, number 4. So the steps are gone, but you guys have been taking notes, so you still have the steps on your paper to reference. Oh, what's the first thing we need to do? Yep, isolate our variable. Ooh, or not isolate our variable, my bad, isolate the absolute value. Well, I see lots of things. I see that the absolute value is being multiplied by a 3, and it has an 8 added to the end. Well, the order of which we work on isolating our absolute value is just like when we getting tongue-tied today. Just like when we try to isolate our variable. All right, so when we've been solving equations in these past 2 videos, 0202 and 0201, anything that's being added or subtracted, you move first. then multiplication or division. So the same will be here as we try to isolate the absolute value. So we first need to move over that +8, and we move that over to the other side by completing the inverse. So subtracting 8. So 3 times the absolute value of -8x. 8 minus 8 right here is 0. 80 minus 8 is 72. All right, my absolute value is still not isolated, so I need to keep going. It's being multiplied by a 3. And those are absolute value bars, not parentheses. So that's why we cannot distribute. So the inverse of multiplication is division. So we'll divide both sides by 3. 3 divided by 3 is 1. So we're simply left with the absolute value of -8x. 72 divided by 3 is 20. Oops, I forgot my bar. My absolute value bar is 24. All right, now is our absolute value isolated? Yes. So what do we do? What's that key step in solving absolute value equations? Yeah, splitting into two equations because we have the positive integer and the negative. We have both of those possibilities. So the inside of that absolute value bar could be a +24, or the inside of the absolute value could be a -24. All right, -8 times x, the inverse of multiplication is division. So we'll divide both sides by -8. So we are left with x is equal to what? Yeah, -3. Ooh, there we go. All right, last but not least, let's try a red one here. -8x equals -24. We still divide by -8. X is equal to, well, what's a positive divided by a positive? Oh. What's a negative divided by a negative? Yeah, positive. So we are left with a +3. There we go. Perfect. All right, before we get to our final example, I have a fun little joke for you, or a dad joke for you. All right, how do bulls pay for their shopping? They charge it. Ha, get it? Charge? Because bulls charge, they run after. I know. Hilarious. Maybe your kid siblings, your kid brothers or sisters will think it's funny. You know. All right. Let's get to our last example. A group of students ran a mile. Maybe they were running from the bull, with an average time of 9 minutes. Individual times were no more than 3 minutes higher or lower than the average. So using the given equation, x, so the absolute value of x minus 9 equals 3, solve to determine the range of times. All right, so we need to solve this to determine our range of times, so our highest and lowest possible time. All right, now is that absolute value isolated? It is. They were nice, they gave us an easy one, which means we can go ahead and split that bad boy. So x minus 9 is equal to 3, or another possibility is x minus 9 is equal to -3. Hopefully you guys have already paused at some point, but if not, since this is the last example, please pause and try finishing this off on your own, okay? And then resume the video and check your work. All right, well, I have x minus 9. The inverse of subtraction is addition. So we'll add 9 to both sides of our equation. Got to keep it balanced. Bring our x down. -9 plus 9 is 0, so that zeroes out. 3 plus 9 is 12. So one of our possible times is 12 minutes. All right, still going to add 9. Only this time we're adding 9 to a negative 3. So that is equal to 6. So our range of possible times would be 6 minutes as the fastest mile, 12 minutes as the slowest mile, all of which pretty good times. All right, as always, thank you guys for joining us for our video, and please reach out if you need any assistance. All right, we are here for you. Have a great evening.